Welcome. This is Volume 1 of the Simplicial Lattice Field Theory series, an 8-paper project that derives the structure of spacetime, the standard model of particle physics, and cosmology from a single geometric object. The question driving this work is simple: even if the answer is not, where does spacetime come from? Most approaches to quantum gravity start with a smooth continuum and then try to quantize it. This series inverts that logic entirely. Today we lay the foundation. By the end of this video, you'll see how the signature of spacetime, plus, minus, the three generations of matter, and the speed of light all fall out of the geometry of one four-dimensional polytope. No extra assumptions. No free parameters beyond two physical scales. Here's the central claim of simplicial lattice field theory. Reggie calculus, causal dynamical triangulations, loop quantum gravity, these are all attempts to describe spacetime using discrete structures. But in every case, the discrete structure is an approximation to some underlying continuum, or a quantization of it. SLFT says something more radical: the D4 root lattice is not an approximation. It is the vacuum. The continuum spacetime we experience is a long wavelength, low energy limit of discrete lattice dynamics, the way sound waves in a crystal are a continuum limit of atomic vibrations. This is not a formal analogy. It is the actual claim. And the remarkable thing is that a lattice this simple, built from a single class of root vectors in 4 dimensions, turns out to be rich enough to contain everything. So what is the D4 root lattice? In 4 dimensions, the densest way to pack spheres is the D4 packing. Its Voronoi cell, the region of space closest to each lattice point, is the 24 cell. And the 24 cell is remarkable. It is the unique regular, self-dual polytope in 4 dimensions. No other regular polytope in any dimension has this self-duality property. It has 24 vertices, 96 edges, 96 triangular faces, and 24 octahedral cells. Its Euler characteristic is 0. And crucially, the cell count equals the vertex count, and the edge count equals the face count. This self-duality is the geometric origin of gauge matter duality in the theory. Each vertex has exactly 8 nearest neighbors, forming what is called a cubic vertex figure. This is our vacuum. Everything else is derived from here. Now here is where things get interesting. Project the 24 cell along any axis. The cross-section you get is a cuboctahedron, an Archimedean solid with 8 equilateral triangles and 6 squares. The triangles are rigid. The squares each have one internal degree of freedom, a fold angle along their diagonal. Now ask a simple question: can the 24 cell contract uniformly in all directions while keeping those triangles rigid? The answer, proven in Theorem 2.2, is no. It is geometrically impossible. If you try to fold all 3 pairs of opposite squares identically, as you would need to for uniform contraction, the volume increases rather than decreases. Volume preservation is violated. The lattice is frustrated. It cannot contract isotropically. Something has to give. What happens when a frustrated system finds its ground state? It breaks symmetry. The unique minimum energy resolution is this: one pair of opposite squares folds. One axis stretches, call it temporal. The other 2 axes compress, call them spatial. The stretch ratios satisfy lambda t times lambda s squared equals 1, preserving volume. This is the simplicial phase transformation, or SPT. It breaks O4, the 4-dimensional rotation symmetry, down to O1 times O3. 1 time direction and 3 space directions. Time is not put in by hand. It is the unique minimum energy response to a topological constraint of the 24 cell. So the SPT selects a time direction. But by how much does the lattice stretch? The virial theorem determines this exactly. After the SPT, the temporal direction participates in 2 independent quadratic energy channels. Each spatial direction participates in only one. Equal energy per degree of freedom gives sine squared theta equals 4/5, cosine squared theta equals 1/5. The frustration angle is theta equals arctan of 2. These three numbers appear again and again throughout the series. Every mass ratio, every mixing angle, every symmetry breaking parameter in the subsequent papers traces back to this single geometric calculation. The consequence is immediate. After the SPT, the effective metric tensor of the D4 lattice is diagonal, 1 positive eigenvalue, 3 negative. That is exactly the Lorentzian signature, plus, minus, minus, minus. In standard physics, this signature is an assumption. Here it is theorem 2.5. The signature of spacetime is a geometric necessity, not a choice. One of the deepest mysteries in particle physics is why there are exactly 3 generations of fermions. SLFT gives an answer. The D4 Dynkin diagram has a unique Z3 outer automorphism called triality. It permutes the 3 outer nodes while fixing the center. Those nodes correspond to the 3 inequivalent 8-dimensional representations of SO8. These are the only irreducible representations of SO8 with dimension 8. A 4th generation would require a 4th such representation, which does not exist. 3 generations. Forced by the symmetry structure of the lattice. Now let me show you something genuinely astonishing. The adjacency matrix of the 24-cell graph is a 24 by 24 integer matrix. Its eigenvalues are 8 with multiplicity 1, 4 with multiplicity 4, 0 with multiplicity 9, -2 with multiplicity 8, and -4 with multiplicity 2. Match these to physics. Eigenvalue 8, the Higgs boson. Eigenvalue 4, the 4 spacetime vector modes. Eigenvalue 0, 9 gravitational tensor degrees of freedom. Eigenvalue -2, 8 spinor modes, all 3 fermion generations. The entire particle content of nature falls out of the spectrum of one matrix from one polytope. The last major result of paper 1 concerns dynamics. The 24 root vectors of D4 form a tight frame. Their outer products sum to 6 times the identity. This coefficient 6 determines the discrete Laplacian, the Green's function, the Wilson parameter, and the gravitational packing coefficient, all at once. The phonon dispersion relation gives c squared equals 3 tau a squared over k. The speed of light is the phonon velocity of the D4 lattice. Not a free parameter. A geometric consequence. Let's step back. From one polytope and 2 parameters, lattice spacing and lattice tension, we have derived the Lorentzian signature, 3 fermion generations, the full particle spectrum, and the speed of light. The remaining 7 papers extend this to the standard model gauge groups, the Weinberg angle, the Higgs mass at 125.25 GeV, fermion masses, mixing angles, and inflationary cosmology. The continuum is not the foundation. It is the limit. Thank you for watching. The full papers series is available on Zenodo, the link is on screen. The next video covers paper 2, gauge groups from the F4 root system. See you there.